Hi, in this video, I'm going to talk about the high availability. Now, high availability is very important when it comes to deploying Cisco collaboration solution. There are two types of high availability available supported by Cisco. One is we call high availability 1-to-1 ratio and 2-to-1 ratio. Now, the nodes, which is the call manager servers or CUCM servers or collaboration application servers, should be deployed in high available infrastructure. Now, what I meant by high available infrastructure is that we're talking about servers with dual power supplies combined with UPS for uninterrupted power supply sources. You should also have multiple power grid to support your power availability. The platform or the servers that you're using should be also connected to multiple upstream switches. Should in case one switch goes down, you should have alternative switch to continue supporting your connectivity. At least you should have two TFTP server or trivial file transfer protocol, which is basically used by the Cisco phone to download the configuration file and should be deployed for redundancy. Call processing node, which is a server responsible for registering phone and processing your call, should be deployed in a one-to-one redundancy, where for every primary call processing subscriber, there is a backup call processing subscriber available. Now, in this particular topic, what you're looking at is one-to-one ratio. Basically, we're going to discuss the high availability option that will help you in case to make sure that you have a redundancy and fault tolerance. So especially in a case where you might have a failure. But two possibility during an upgrade process, chances are there will be one of the server may not be available. Well, in that scenario, you do not want to wait unnecessary loss of bunch of functionality during that upgrade process. Now, there's one thing, of course, the server goes down. I mean, that's given the scenario that, hey, is down. So you have a backup. Let's move to the backup server, continue to function. But there are times where server will not be down. Maybe you have to take it down intentionally for upgrade purposes. While during that moment, you also do not want to lose the functionality. So let's have a look at few examples of how we can go about doing a high availability. There are really two major designs that we have available when it comes to high availability. First one we're going to look at in this particular video we're going to discuss called one-to-one relationship. Now, if you take a look at in this scenario, you have 10,000 phone deployment, you have 20,000 phone deployment, and then you have 40,000 phone deployment. When you have a deployment in this particular manner, what's going to happen is you're going to decide how many servers you're going to need, how many phones you're going to register, and whatnot. Now, I understand there may be different size and type of different companies. It is simple one to follow if we keep the numbers quite simplistic. I understand that some company may have 7,000 employee or phones, or maybe 8,900 phones, right? Well, in that are 11,560 phones, for example. Well, if we try to use this 10,000, 20,000, 40,000 as a baseline, it becomes easier for us to calculate. And of course, you can then keep it within a range. Now, one of the things that I want to highlight is that when we start with a 10,000 phone design, as soon as the network has reached more than 1,250 endpoint. So recommendation is that anything below 1,250, it is highly recommended that you should have one publisher, one TFTP piece of it that is dedicated for that function only. So that means the publisher and TFTP should be function independently without having to register any phone to it. Now, meanwhile, meaning that it is not going to be running the call manager services. It is going to be functioning and functioning in any other type of environment. It is not going to be doing music on hold or conferencing or extension mobility, stuff like that. It is exclusively going to be used as a publisher for database accessibility and is going to be used as running as a TFTP server to continue to push the configuration file. Now, the redundancy point of view, TFTP server should definitely have a second TFTP server for an extra redundancy. However, discuss here is really for scalability point of view once you cross that threshold of 1,250 phones. it is no longer a good idea to have one TFTP server co-reside with the call manager services. Now, when you reach that threshold, we should split the functionality of TFTP, put it on a dedicated server, and possibly a publisher on a separate server. Now, again, for fault tolerance, we should look at having two of these servers to allow for functionality purposes. From the publisher point of view, there can only be one publisher. So there can be only one master. There is no subscriber that can be promoted to publisher. So the very first server that you install in your environment is going to be the publisher, whereas subscriber is basically a subsequent server that you build and usually have a read-only copy of your publisher database. Now we will see the publisher and TFTP at the top in this scenario being in one server. For now, example, just for simplicity purposes. The reason why, of course, because we in this scenario we kept dedicated because the threshold of 250 phones has been reached. So therefore, we are going to dedicate the publisher and TFTP server on a dedicated server. Then we're going to have one publisher primary, also one subscriber as a primary call processing server. So the two servers that you're seeing, they're both running the call manager services. However, they're both running the call manager services, but one of them will be the primary, one will be the secondary server. In this case, what you're going to do, you're going to create, let me erase that. So you're going to create one group with a publisher and one with the publisher server, or not necessarily publisher, a subscriber being at the top of the group. Second server in that group is going to be the secondary. So at this moment, what's going to happen is the phone will contact the primary server as a primary, while the secondary server as a secondary in the list. To do that, what the phone does, it sends a keep alive every 30 seconds to the primary server. So first of all, the phone is going to download this configuration as an XML file. In that configuration file, it will tell you which one is your primary, which one is your secondary, and which one is your tertiary server. So the phone will send a keep alive every 30 seconds to the primary. Now, should the primary server goes down or does not respond to an acknowledgement of the keep alive, then it will contact the secondary and register. While the phone sends a 30 seconds keep alive to the primary, it will send a keep alive to the secondary server every 120 seconds or 120 seconds. So what's going to happen is that you just want to make sure that there is a secondary server available. So in this scenario, there's a possible that during upgrade process where one of the server goes down because you have to take it down, you do not necessarily lose all the functionality because you have the second server continue to function. So it's not just about an outage. It could also be intentionally, downing a server because of that requirement. Now let's take a look at a few of the examples how we can go about and do that for a higher number of phone. So if you take a look at in this scenario, you have 20,000 phone. In that scenario, you'll have two call manager group, as you can see, where you will have one primary and one secondary server. So sorry, backup server. So like this, you can split the environment the way you want to and yet provide call processing in a primary with a backup, call processing on another primary with another backup. So you could do is register the first 10,000 phone here and the second 10,000 phone on the second kind of group. So this is kind of like how you distribute your load. Now you gotta keep one thing in mind, that if you are holding 10,000 phone on that particular server, the backup server should be able to capable of handling the 10,000 phone. So the resource of the backup server should not be less than the resource of the primary, because if the entire phone is going to fall back, then there might be a resource issue should you lose connections. So make sure that the server can handle both topics. Now, if you're going 40,000, you would need 4 primary and 4 backup in 4 separate groups. Now, only to 2-to-1 ratio, which is in other case where every group you should have one backup. Every group of 2 primary, you should have 1 backup. So in this case, 10,000, you have 1 primary, 1 backup. That 20,000 phone, two primary, one backup. Okay, so you got group one, and then group two will be like this. Okay, so you have group one will have a primary server A primary, server B secondary. Group B, you'll have server A primary, server B secondary, or reverse the order, doesn't really matter. But again, in this scenario, you gotta keep one thing, again, the same thing in mind. If both of these server can handle 20K, the backup should be able to handle 20K at if both server goes down. Now, chances of both server to go down, very rare. But if that happens, then there could be some question regarding the designers and the administrators rather than the capacity planning itself. You want to make sure that the engineers who design it, that you held them accountable for that. Why would these two servers go down at the same time? So make sure that the backup server should have enough capacity to handle that. 40,000 phone, as you can see, 4 primary call processing with the 2 backup, 1 backup for 2 group at a time. So this is one of the way of provide redundancy when it comes to choosing a redundancy model. Now, it's not just about how many servers and how many primaries, whatnot. About when it comes to high redundancy, you got to look at things like clustering. Okay, you want to look at failover, functional redundancy, redundant link, geographical diversity, stuff like that. So failover redundancy, for example, clustering. The first server you install is going to be the primary. Second server you install is going to be second subscriber, and so and so. You have to install the publisher first. You cannot install the subscriber without the presence of publisher, because during the installation of subscriber is going to ask you for the primary server's details, host name, IP address, and the secret access key, which is basically like your password phrase. Now, when you build a cluster, a call manager cluster can have up to 21 servers. You're looking at one publisher up to 20 subscribers. Redundantly, you should also have a WAN link, because if your users are depending on the WAN to communicate with your call manager and the WAN goes down, obviously you will have a failure. So whole point of high availability, that there gotta be always a way to reach the destination. Geographical diversity. What if your building is succumbed to earthquake or some sort of natural disaster, or even for behavior of some unusual activities? Well, in that case, you want to distribute the servers into multiple location or cities, or maybe building. Doesn't have to be multiple cities. So geographic diversity is very important, as equal to having a clustering environment. Then you got to look at your site-based design, like how big is your deployment is going to be. One of the common question they might ask is that what size of the deployment was your call manager platform or collaboration platform. In this case, the size refers to the number of users, not how big your server is. So size usually refer to the number of users, which will translate into quantity of IP, telephones, voicemail box, presence, watchers, and so forth. Then you have network connectivity to watch out. What if your primary link goes down? Do we have a backup? And if you have a network connectivity, do you have enough bandwidth? Do you have quality of service enabled on the bandwidth? Because the latency and reliability is going to be a very big factor when you have a multi-site with a centralized call processing server. Now, you also want to look at your bandwidth reliability, because having a 100 MB connection is not good if it's not reliable. So you want to make sure that it may directly affect your deployment model. Because if your bandwidth is not capable of big enough to handle the traffic, then you will have a quality issue. Or if it's not stable, then you will have calls being dropped because link went down, for example. So you want to make sure that your bandwidth is not just good, but also reliable. Power availability. Okay, you can have all the UPS in the world, but if your power grid goes down because you're relying on one power company, well, that can be a problem for high availability. So you want to make sure that you have a secondary power grid in order to ensure that you want to provide true high availability. But then again, also don't forget things like other factor, environmental factor, such as heat, humidity, vibration, so forth. And finally, but not the least, is you could have $1 million equipment and network, but if you don't have a qualified person to manage it, then you could literally cause serious problem by having someone who's not qualified to administer the system. So you want to invest on your people. So make sure that the engineers that you hire or engineers that are going to manage the system are qualified, certified, and they went to Voice Bootcamp for training. All right. So these are some of the thing about high availability. Then comes to design deployment. What kind of deployment model you want to follow? Cisco has three major deployment model: campus deployment, multi-site across multi-site with centralized call processing, and multi-site with distributed call processing. And then you have something called clustering across the WAN, which is basically a campus across multiple WAN. A campus deployment where you got one building where all your servers and users are residing. So usually single office, and you have a data center. You put all the servers there, all the users are sitting in your office using the Ethernet connections to communicate with their servers. The good thing about this type of deployment is that you can maximize up to 40,000 phones, and you can use up to 2,100 gateways on SIP trunks. And because everybody is using on a local area network, you get to choose the highest codec available, G711 or G.722, for the best quality you can think of. You could use the PSTN for all your outside call, or you could use a SIP trunk for all your outside PSTN related call. Now, if you're going to use a single site deployment, usually it means that there is no remote branch offices. So therefore, you get to choose to use all the highest quality equipment on the central location. Whereas if you're going to the multi-site WAN with centralized call processing, what does that mean is that you got the head office where the servers are located, but then you also have a branch office, which is a location maybe far away from you, but doesn't have a data center of its own. So the phones that you have or the devices that you have on that location, they will use the WAN to register to your head office cluster. So that's called multi-site because you got the head office and you got the remote location, but the centralized portion means that call processing server is centralized. So therefore, the whole branch office will depend on this WAN connection to provide communication. Now, that's one of the reasons why we want to make sure that you have a fully redundant WAN link, fully redundant layer 3, layer 2 switches as well. When you're deploying a multi-site WAN, you're still restricted to 40,000 phone, and you still have restriction of 2,100 gateways, but you can go up to 2,000 locations. So that is what multi-site WAN with a centralized call processing mean. Now, and additionally is that because now you have a branch office, sometime you may want to restrict the number of calls going to a branch office. To do that, you could use call admission control or CSC. Now, call admission control, there are two types of call admission control available in Cisco: CSC, call admission control, and RSVP. We will talk about that more details later in the course. Now, call admission control will limit the number of calls going to branch office. So let's say in a branch office, you have you're only allowing 5 calls so that you do not oversubscribe the link. But now suddenly the 6 or 7 calls are coming in. If you're looking at from a high availability perspective, you do not want those calls to fail. But because there's a restriction on the bandwidth, the call will fail. So what do? You could always configure an additional feature called AAR, Automate Alternate Route, that basically says if the call is about to be dropped because of lack of bandwidth, please reroute the call using the PSTN. So there are some configuration that you can do where you can use the T1 or E1 or SIP trunk to reroute the call across the PSTN network to that location. Now, because the remote site will depend on the WAN to communicate with your head office, what if the WAN goes down or the router on the other side goes down or Ethernet goes down, for example? You cannot have redundancy in every location. Sometimes they are restricted due to the fact that there's not enough business there or there's not enough company there. So sometimes you're stuck with one service providers. So in this case, what do you want to do? That you do not want to rely on the internet to register the phone from the branch office, because if the internet goes down, those phones will not be available. So what do you want to do? You want to use something called SRST, Survival Remote Site Telephony. So if I go back to my previous slide, what you'll see that there is a router right about here, and I can configure that router as a call manager, so that when these phones lose connection to the WAN due to the WAN being not available, these phone will register to this router as a temporary solution. This is called remote site survivability, and it is a temporary solutions. So SRST can be configured on a local router to provide mini call manager services. Now you could use SRST, which is a license-based solution, or you can use Call Manager Express to achieve the same thing. Now there are differences between them, which we will talk about that later in the subsequent courses in CCNP module. So you could use CME, or SRST. So again, multi-site WAN with centralized call processing. These are some of the features. If you are a big company, then you may have to, or if you're a multinational company where you have organization in multiple countries, and they have different rules and regulation for VoIP or IP telephony. Well, like pretty much every country has their own telecom restrictions. So sometimes because of that, sometimes because of your own corporate policy, you may want to isolate each network separately. So you may have a call manager cluster for Toronto employees. You may have a separate call manager cluster managed by a separate team in San Francisco. And you could have another one in India. Well, if you have a scenario like that, each location could have either campus design or a multi-site with a WAN or multi-site distributed, but they all can be communicated with each other by using a central call manager server known as Session Management Edition. Now, Session Management Edition is just another call manager cluster. And the purpose of that is to communicate with all the other cluster independently by using either SIP trunk or ICT trunk. So you could use a multi-site because each location is a separate site, and distributed because they're all independent. So you want to send a call from Toronto to let's say India, you could say, well, send the calls to this distribution network, SME, and then that call will go to India. Okay, so that's how the communication works for a multi-site. With the multi-site, you can literally have about unlimited number of phones. However, to do that, you must create unlimited number of location. So you got campus design, 40,000 restrictions, multi-site with the centralized call processing, 40,000 phone registration restrictions. For the distributed, you can keep adding 40,000 as many resources are available. Now, with a multi-site distributed, you could use different codec for different region. You could use high availability codec within your internal, where you could use G729 across the WAN. So this is something that you have to decide based on your WAN, your environment. Again, maximum number of phones are restricted to the per campus design. So that's something that you have to get around with it. Clustering across the WAN happens when you want to distribute a single campus cluster. The servers will be distributed in a multiple location. Because you may have 25 employee working in San Francisco, it doesn't make sense to register their phone across the WAN to the head office in Toronto. What you can do, you can keep the publisher and a subscriber in Toronto for the Toronto employee, and a subscriber sitting in San Francisco for San Francisco employee. Now, to do that, you got to make sure that the server in San Francisco is 80 milliseconds or less round trip delay with the Toronto publisher. So the round trip delay has to be 80 milliseconds or less. Now, what happens if the round trip delay is longer than 80 milliseconds? Will that stop working? No. It's just simply out of sync. It will be out of synchronized so that the database will not be up to date. If you make changes in Toronto, it will not get pushed to the subscriber in San Francisco. So therefore, information may not be accurate. So you have to keep that in mind. So that is what one of the restrictions of having clustering across the WAN. Now, Session Management Edition is basically nothing but another call manager server with no IP phone register. So only thing you have on that cluster is some sort of trunk. Now you could use SIP trunk, MGCP trunk, H.323 trunk, ICT trunk, doesn't matter. But all it is just a trunk. No endpoint license are required for that. It enables aggregation of multiple call manager and referred as a leaf system. Can be used to migrate a deployment of multiple PBX and associated phone to the call manager cluster with an IP phone and relatively few trunk. It is used to connect to third-party unified communication systems such as PSTN connections. In this scenario, SME is just another call manager cluster with no endpoint. Now, when we talk about redundancy, how do we achieve that redundancy? Well, first of all, to achieve that redundancy, you will have to use a concept called CUCM, redundant call manager group. So the call manager group, for example, can have up to 3 call manager server. You have primary server, secondary server, and you will have tertiary server. Now, each call manager group, the server will be prioritized in top-down approach, primary, secondary, and tertiary. The server can belong to multiple call manager group. It's okay. So the primary server, like the server A, could be a primary in one group, could be secondary on another group. Now let's take a look at how this how this group is created and how you can organize it. So we'll go to our lab environment, and in this lab environment, I'm going to log into my call manager. All right, so here you'll see that we go to system menu. Under system menu, you have CM call manager group. And in the call manager group, by default, it's supposed to come with the default group. Now, I have customized this call manager. You'll see Toronto and SFO. The Toronto was the default one. We just renamed it. And in this scenario, I can have my first call manager server on the list. So that therefore, that is the primary. If I had a second one, it will be the secondary. If I had the third one, it will be the tertiary. If I have the server on the top, I can select them and drop it down into the list. And then I can change the order by going up and down using the up and down method. So you can create as many call manager group you want, but maximum 3 servers in the call manager group. So the remaining servers, remember the remaining in a call manager cluster, you can have up to 8 servers that can act as a call processing. The remaining 12 to 13 server can be used for additional resources such as conference bridge, MTP, TFTP, and whatnot. So, but at any given day, our entire cluster, only 8 servers that can actually register the phone and process the call for you. So that is one of the restrictions that you have to follow when it comes to clustering across the network, clustering in call manager. So as I showed you in this lab, how to maneuver through the call manager group, and it's pretty straightforward. One, you can create a group and then assign the group to a device pool, which will then get assigned to the phone, and the phone will then download the IP address of those 3 servers into its XML configuration. And that's how the phone will know what to do next. All right, so that's pretty much it for this particular video. Hopefully you understood the call manager redundancy and how the deployment model works. Thank you for watching, and I will see you